Hi, this is Lisa Knight, and I'm going to take a moment to go over your Chapter 1 self check. I'm going to go over a couple of the topics in each of the three sections of your self check that I think are important for you to focus on. The first thing is the first section, the introduction, had you answer some free response questions where you had to explain some of the concepts. The biggest thing I want you to come out of this section understanding is the difference between a law and a theory. And the very first question asked you, a friend tells you that a scientific law cannot be changed. You had to state whether or not this is correct and then briefly explain your answer. And you should say that that is incorrect. All scientific laws can be changed. Scientific laws are exist because over time you have theories that have been tested and tested and tested repeatedly, and have been shown to be valid. But over time, we can have experimental evidence that shows that um, that those theories are wrong and they can change. So, as our experimental database changes, our scientific laws can be changed over time. An example would be that we used to think the Earth was at the center of the universe, and we no longer think that. We now know that the sun is at the center of the solar system, and that our solar system is part of a galaxy, and that the galaxy is part of a group of galaxies, and that the group of galaxies is part of the bigger universe, of a bigger system of galaxies. So we have a much broader sense of how things fit together, and I'm sure that's going to change over time as well. The next thing is understanding um, that a theory is not, in science, is not a theory in the sense of what we think of a theory in everyday terms. So a friend says that he doesn't trust scientific explanations because they're just theories, which are basically educated guesses. So you need to understand that a theory is a scientific explanation that has been repeatedly tested and supported by many experiments. It's not a hypothesis. So make sure you understand the difference between a scientific hypothesis and a scientific theory. So those are really the big concepts out of that section that I would like you to focus on. In the second section, this is a very important section because in physics we are going to be making lots of quantities. So the first thing that you need to understand is that we use dimensional analysis um, to to ensure that our equations are correct. And that means that you need to understand the units that we use for measurement in physics. The base units that we use are kilograms for mass, seconds for time, and meters for distance. So our derived units for velocity or speed would be meters per second. For acceleration would be meters per second squared. For force would be a kilogram times a meters per second squared, or Newton, and so forth. Chapter 1 has a chart that goes over all these units, and you are responsible for understanding and being able to recognize different quantities by their units in this course. There are several videos that go over this in the math review for the course, so you are responsible for that. You are also responsible for being able to use dimensional analysis to verify whether equations are dimensionally correct. So let's take equation 3 here. If we were to put in the dimensions or the units for distance and time on the left-hand side of this equal sign, the units on the left-hand side of this equation would be meters times seconds. So to be dimensionally correct, if we were to plug in the units for each of the quantities in each part of the equation on the other side of the equal sign, they should mathematically cancel out to end up being also meters times second. So the question is, when I put in the units for velocity times the units of time squared, do I get meters times seconds? And when I add that to the units of acceleration times cubed, does that also end up as meters times seconds? Well, velocity is meters per second times second squared. The seconds will cancel out, and I'll end up with a meter second. And this is meters per second squared times seconds cubed. The seconds will cancel out, and I'll end up with meters seconds. So meter seconds plus meter seconds ends up with meter seconds, which is equivalent to meter seconds. So equation 3 is dimensionally correct. So it turns out that equation 1 and equation 3 are dimensionally correct. Equation 2 is not. So you would need to be able to show that mathematically. The other thing that's important in this section is that you do need to be able to use dimensional analysis to make conversions. You need to be able to convert 342 meters per second to kilometers per hour. And that means that you need to understand and be able to locate, or if you are given the conversions, that 1 kilometer is 1,000 meters and 1 hour is 3,600 seconds, you should be able to use dimensional analysis to convert 342 meters per second to kilometers per hour correctly. And if you cannot do that, then you need to um, um, contact me so that we can go over that and I can meet with you online to help you with that. Your book also does a good job doing that, and the Khan Academy video that I provided does a good job reviewing that with you. So this section is all about making sure that you know how to do conversions. And it's important for you to be able to convert in this class because our base units are always in meters and seconds and kilograms, but you're not always given meters and seconds and kilograms. You may also want to review how to enter scientific notation into your calculator correctly, because sometimes that is a problem with getting the correct answer. The third section is always about accuracy, is always important as well because of the significant figure rules and rounding. So you will need to review those, and I have provided an additional lesson that I created to review those rules with you. The biggest thing in this section that you need to know is the significant figure rules and how to count significant figures, and the rules for adding and subtracting significant figures, and the rules for multiplying and dividing significant figures. So remember that when you multiply and divide, you're going to round your answer to the least number of significant figures of all the numbers in the calculation. So in this number 30, you have 4 sigdigs, 3 sigdigs, 5 sigdigs, and 3 sigdigs. So your answer should be rounded to 3 significant digits. In 31, you're multiplying because you're squaring something. The least number of sigdigs is 3 sigdigs, so your answer should have 3 sigdigs. In number 32, you're multiplying. The least number of sigdigs is 3, so your answer should have 3. So in number 33, 34, and 35, you're given a heart rate, and you're going to convert that to numbers of beats based on the number of sigdigs in the number of beats that you're given in each problem. So this one's a little tricky because what they're doing is you can kind of consider the heart rate as a conversion factor, and conversion factors can have an unlimited number of significant digits. So you don't really need to count this as the number of significant digits here. Um, what you want to do is count the number of significant digits in the number of years. So in number 33, there's two significant digits, so the answer should have two significant digits because you're multiplying for this answer. In number 34, there's three significant digits, so your answer should have three significant digits. In number 35, your answer, oh, I'm sorry, wait a minute. Oh, I misspoke. Um, this is not a conversion factor. This is a measurement. It's 72.0 beats per minute. 72.0 has three significant digits. So all of your answers should have, uh, you're multiplying, so you should go with the least number of significant digits. So in number 33, you've got 2 sig digs times 3 sig digs, so the answer should have 2 sig digs. In number 34, you have 3 sig digs times 3 sig digs, so your answer should have 3 sig digs. In number 35, you have 3 sig digs times 3 sig digs, times 4 sig digs, so your answer should have 3 sig digs. Some people were trying to round by the number of decimal places. Remember, when you multiply, you always round by the number of significant digits. Same thing with division. It's when you add and subtract that you round by the number of decimal places. So multiplying and dividing, you round by the number of significant digits. So make sure that you are very careful about that rounding rule because it's a common mistake. Now, when you're preparing for the MCAT, it's important for you to know how to find percent uncertainty, and that is covered in your book. It's very clear. They do some great examples of that in your book. Whenever you do these problems, when you look in the lower right-hand corner of the problem, there is a link to this section of the book where they give you examples of how to do those problems. So I suggest that as you do the problems that you go to that link and open it up and use that as a way to review. In this class, we will not calculate percent uncertainty. Instead, to determine how uncertainty is propagates through a problem, we really will be focusing more on percent error and really be looking more at the accuracy of the values that we calculate in lab. So we're going to be comparing values that we calculate in lab to known values instead of looking at how the error propagates through our lab analysis, our data analysis using percent uncertainty. We're going to be looking at the accuracy of the findings in our lab. So we'll be finding percent error by calculating, by comparing our final answers, our final values that we've come up with in lab to the known values of what we should find in lab. So that is covered in the review lesson that I've given you, and it will be covered as we go from lab to lab. So in terms of what you need to be able to do in class, that will be covered as we get to it. But in terms of preparing for your MCAT and other tests to get into different programs, you should be familiar with percent uncertainty. And most people did okay on that.